Chuck,
Yes.
I got a fast one for you.
Alrighty.
This one is going to be about wheels.
I'm gonna say, I'll say a bit pedestrian for you. Just
Okay. Would it be any more pedestrian than water towers?
ooh, good point. Only our
went viral.
Still the most popular one of these that we've done, I think.
Would have never thought that one would have landed the way it
Couple
did.
million people were just like, water towers, man. Gotta know about the water towers. This is amazing.
Got like 5 million views.
Yeah, I know, that's right. Oh my God, water towers.
So maybe the wheels will do the same thing. You ready?
Okay.
Did you know that if you're driving down the road, pick a speed, 60 miles an hour.
Nah, that ain't me.
Oh, okay, whatever. Sorry.
You got to bump that up by about 25 miles. And now we talking.
At whatever speed you're going,
Okay.
there is a part of your car
All right.
that is going forward at 0 miles per hour at all times.
All right. This already got interesting because I have no idea what you're talking about right now.
There's another part of your car
Okay.
that's going forward at twice that speed at every moment.
Oh, God. Okay.
What? I'm just saying.
Jesus.
Okay.
Oh,
All right.
okay.
So, okay, you ready? Okay, are you seated?
All right.
Okay, here we go.
Okay. Here we go.
Okay. It's all happening in your wheels. So, the part of the wheel at any moment
Oh, my
that's
God.
in contact with the pavement is not moving at all.
That's right. Damn.
No, if your car were skidding,
Right.
then the part of the wheel in contact with the road would be moving forward
Would be moving forward.
at the rate you're skidding forward.
But that's why you're
Okay.
moving forward.
It's why you're moving
It's
forward.
why you're moving forward.
Because part of the wheel is not moving at all.
Exactly.
Correct.
Because
Okay.
if it were, you'd be spinning in place.
You'd be spinning in place. Correct.
By the way, okay. Now, you know what, man? You did it again. You did it again. Because I'm gonna let
I'm just
you know.
saying.
I gotta say. First of all, this is what I'm gonna do right now. I'm gonna publicly apologize to you for all that shit I was thinking. Because I was
Before I
thinking
began.
let me tell you something. I was thinking some stuff. I'm going to apologize to you right now because you were like, all right, Chuck, we're going to talk about wheels. I'm like, this brother done lost his damn mind. We're going to talk about wheels. Seriously?
Yeah.
You did it. Go ahead. Let's go for it.
Let's keep going. Going. So the center of the wheel,
Right.
which is, it's spinning, but the exact center is going forward at the same speed the car is.
Absolutely.
The top of the wheel is going forward at twice the speed of the car.
Twice the speed of the car. Just like
At twice the speed.
Right. Wow.
Okay, because notice if the chassis of the car is moving at the speed of the car, obviously, the top of the wheel is moving faster than the chassis.
Right.
Okay? It's moving past the chassis. The top of the wheel well. The wheel well, the top of the wheel well is going forward at your speed, at your speedometer speed. The top of the wheel is going faster than that to come around to the bottom so that it's not moving at all. And if you run the math on that, you get 0 at the bottom, the speed of the car in the middle of the wheel, and twice the speed of the car at the top of the wheel. And so this is the geometry, the math, and the physics of an axled wheel on any moving vehicle. What are you doing? Chuck is smoking something.
I'm just saying, I'm ready to talk about this all day.
Chuck is smoking. Okay, but wait, there's more.
That's awesome. That is awesome.
But wait,
and
there's more.
Because I'm picturing a dot on the wheel and a dot at the chassis. And then it comes up, it has to go faster than the top.
Faster.
Has to go faster. So it could come
than the top of the wheel well.
That's right.
So that it can come around. Correct. So now think of the wheel that's on a train. There's the metal flat part that touches the metal rails. But then there's another part. It's like a coupler. There's an outer part that extends outside of the track. Can you picture this? It's not like just rolling on a track.
Yeah,
it's like a lip.
Like a lip on the wheel itself.
A lip that extends outside of the track, which enables the train to stay on the track. Otherwise, we'll just drive off, right? So these lips that are exterior to the wheels keep the train aligned on the track.
Right.
But here's what's interesting. They dip below the contact point of the wheel and the rail.
Correct.
That by a little bit, by whatever it is, they dip below. Well, if the top of your wheel is going twice the speed, the center of the wheel is going the speed, the bottom of the wheel is going 0, anything lower than the bottom of the wheel is moving backwards.
Oh, snap. That's right.
Okay.
It's going in reverse.
It's going reverse. For any train, there are parts of that train that are moving backwards on the track at all times.
That's pretty wild.
Just picture that. There's the wheel rolling. Right. The part that's below the contact point is moving backward. It actually lands in a place behind where it started.
Right.
That means it moved backwards.
That's right. That's insane.
I just thought I'd put that out there. I know it's nothing deeper than that. It's
the next time I tie up a woman and put her on the tracks, I'm going to let her know that you're going to learn something.
Is this what you do, Chuck? Okay.
As I twirl my mustache.
Now, here's something interesting. Are you ready?
Go for it.
So that means there's a part of your car that's going at all speeds from 0 up to twice the speed of the car, correct?
That's right.
Okay. So imagine this. Imagine attaching some device to your wheel that sends out a microwave signal, and you can adjust it up or down, okay? From the center of the wheel to the outer rim, and sends out, or from the center of the wheel to the bottom, sends out a microwave signal that will report a speed of your car at any speed you choose. So the police officer's there with the radar gun, with the return signal that's going 30 miles an hour, even though you're going 60. They'll get the reflected signal off of your car, right? But if you can override that with a more powerful signal sent from your wheels, you can broadcast any speed you choose down to 0 if it's attached to the wheel.
Right. That's the speed I'm choosing, by the way.
Well, you can't do 0 because they know you're lying.
Well,
but
that's
any place between the center of the wheel and the bottom
of the wheel,
you can broadcast a speed of that spinning wheel at any speed less than your actual driving speed. To configure this would be really weird, and how to make that happen, because it has to be moving with the tire. I don't know how you would design the engineering of that, but it's just something to think about, because there's always a part of your car that's going everywhere from the speed of your car down to 0 and up to twice the speed of the car.
Well, maybe, when the cop pulls you over, you can just tell him, I don't know what speed you recorded, but I don't know. You should have been looking at the bottom of my wheels.
Yeah, that'll work in court. So that's all I have to say about wheels.
That was pretty damn good. I mean, sorry, pardon my language. That was pretty doggone good. I'm completely surprised, taken aback by this one.
Yeah, and there's another kind of wheel, which is the shape of the object that rotates within a Wankel engine. So if you imagine an equilateral triangle, but curve the corners of it and make the sides a little bit convex, right? So it's a triangle.
I had a Mazda once.
Oh, you did? Was it with a Wankel engine?
Yeah,
okay.
I had a Mazda.
So that shape, interestingly, the distance from the bottom to the top remains the same no matter how it's oriented. Right. So if you roll it along I made one of these shapes. In fact, I don't have one with me here. We might have to do another explainer.
We used to call them spirographs when I was a kid.
Okay, yeah. So they're related. They're related geometry to it. So if you take a plank and place it on top of one of these triangular shapes and roll it, the plank will be absolutely steady. Even though it looks like the thing is bobbing up and down. It's because there's no central axle to it.
Right.
Okay, we think a wheel that gives you a smooth ride needs one central axle because a wheel is the same distance to each point on the rim. You can design a shape where the top is always the same distance from the bottom, even though the center is moving in your spirographian sort of way.
Nice.
So I actually built one of these when I was a kid in woodshop in 7th grade, and I don't think it's with me here.
That is
it's in a closet somewhere. I'm gonna have to dig it up, and we'll do another one. Just fun things to do with a Wankel engine.
Nice. Yeah. It's an unfortunate name, but yeah.
I know, right? It's a little weird. It is a little weird, but it's one of the many engines that have been developed over the years to convert chemical energy into kinetic energy. I know. We'll do an explainer just on engines and the history of engines.
Oh, that's a great one.
Why they differ from each other and where they're headed. That's a good one.
That is a good one.
And now you know that part of your car, it ain't moving at all.
But don't use that as the excuse when you get pulled over. That's it.
Or don't experiment with how the cop will react if you give that as an excuse.
Right.
You don't want to experiment. All right, Chuck, we got to call it quits there.
All right.
It's been another explainer. This one just on wheels, in case you never knew. Chuck, always good to have you there.
Always a pleasure.
Neil deGrasse Tyson here, 4-star. Keep looking up.